Okay, let's get going. It's 6:17. This is video number 132, and it's kind of like an obvious topic to probably a lot of you, where we're going to apply the math that we've been doing, obviously, to geometric shapes, particularly, almost exclusively actually, to rectangular shapes. And here's 2 dimensions, here's 3 dimensions. You should be very familiar with that by now. Obviously, in the first case, they give you the area and they ask you to find the perimeter, okay? And in the second case, they give you the volume and they ask you to find the lengths of the edges. So this is just typical stuff that you did in 8th grade. But now we can talk more about factoring and using our factoring to divvy this up and find out what potential perimeters there would be or what potential lengths of edges there would be. Because X would always represent a number, of course, that would have to be restricted. We talked about restrictions a little bit. You'll see them a lot as you go ahead. But given restrictions, you can imagine a rectangle, just to make the point, and then I'll get on to the math. And you have a rectangle, and you say the area is 12. Well, what could be the possible lengths and widths? Well, there's 12 times 1, 6 times 2, 4 times 3, right? And when I added those all up, I get different perimeters. Well, it's the same thing, of course, as always, with these numbers or these algebraic expressions, or to use the topic that we've been doing for the last couple of weeks, these polynomials, okay? Representing, in this case, rectangular shapes. So let's do a 2-dimensional example. Obviously, it's 2 dimensions. This would represent that. And so if I factor it, then I know the length and the width. Because after all, isn't it true 1,000,000 times over that length times width equals perimeter? So, area. Sorry about that. Don't want to do the video over for that. Okay, so length times width equals area. And so there we go. If I can factor this, if it's factorable, then the length times the width would just FOIL out to be the area. Then I could mark it arbitrarily either side, add them up, and find the perimeter. So in high school, they always ask you to do that, okay? All the time. So let's factor this guy. 6 times 3 is negative 18. And what 2 factors multiply out to negative 18, but at the same time add up to a positive 7. And anybody who's thinking about this, you'll have to work it out. If you can't do it, then you keep practicing until you get it. 9 times 2 is negative 2 is negative 18, and 9 minus 2 is 7. So there's the key in any order. 6x squared plus 9x minus 2x minus 3. Okay? And I'll erase this work so the clutter doesn't get in the way. And now I'll factor out the 3 and the x. So there's 2x plus 3. There it is again. No need to waste time there. What belongs there? Obviously the 1. So the factorization is 3x minus 1 times 2x plus 3. So what does the Regents want you to do? Well, this might be the length of this, the width, in any order. So you want to find out what the perimeter is. So I go back to my rectangle. And in any order, I guess if there were restrictions here, we could work on that, but we won't do that here. The Regents doesn't even take that into consideration at this point. So there you see, I arbitrarily did that. And now, to figure out the perimeter is the easiest thing in the world. I'll just add this twice. Any way you want to do it. I'm just doing it the old-fashioned way. I could multiply them, distribute them, all sorts of methods. There's 6 minus 4, 2, which is 4. And there's 6, so there it is, 10x plus 4 is the perimeter. Very typical. There, by the way, it's worked out, okay? I added them up over here and got 10x. Get that down a little bit. 10x plus 4, and I'll hold it there for a little while. Sorry I missed the camera there, but you can follow what I did from top to bottom, and I'll give you an assignment today that will allow you to practice doing this kind of stuff. Very easy if you think about it. Okay, so I'm going to erase this now, and you'll get to practice it, obviously. It's really just practice for factoring. And now you should be getting it down, if it's easy. Okay? And I'll give you lots of exercises that will go over everything I've done in the last day or so. I'm not going to move on beyond this today. Give you a chance to practice so this means something to you. So there it is. There's the length, there's the width. Go over here again. There's the length, there's the width, there's the area. We started with the area, we ended up with the perimeter. If you remember earlier in the course, we started with the perimeter and we ended up with the area. So we're just going back and forth. These are just like numbers, okay? All right, so 2 dimensions. High school kids should definitely be aware of, the 8th graders as well. 3-dimensional shape, the rectangular prism. And we've certainly worked with them this year. So this should be no shock that if I can find 3 factors here, then I'll be able to find the edges and work out the edges. So I look at this right here, and I write it out, 18x cubed. And you have to have watched the video yesterday to be able to do this problem. So we're hoping that you do those kind of things. And now I center my attention over here. If I factor it, I'll be able to get 3 edges, okay? So what's the formula for the edges? Well, there are 4 of one plus 4 of another. So what is it? Length, width, and then 4 of the height. So that's basically what I'll do. And these are interchangeable because, like I said, they only represent possibilities. Again, to make the point, if you say the volume of something is 27, well, one volume is 3 cubed, right? But another volume is 1 times 27. So when they give you a number, there are many possibilities, and maybe limited if you consider only positive numbers. But if you consider any kind of number, there are lots of possibilities. There's not only one answer. So in this sense, the math is giving you all the possibilities with the with this factorization. So we probably suspect that these terms are not coprime. That's pretty obvious to anybody who's been doing the math. What number can you factor out? What term, I should say, can you factor out? And I think most kids would see 3x. And what's left? Whoops, again, working this out live and trying to keep down on the mistakes, working backwards. There's x, okay? Careful, we'll check ourselves again, and there's minus 2, okay? So let's go backwards. This times this is this times this is this, and this times this is this. So I factored out the monomial, which is 3x, which is going to be one of the edges, okay? And now I have to factor this. I presume it's factorable, or why would the Regents give it to me in the first place, right? This would be the factorization, would be the end of the problem. All right, so let's see. 6 times negative 2 is negative 12, and 4 times negative 3 equals 12. So without wasting time, like I said, I can give you more if you communicate with me in that sense. But I'm going to assume that you got plenty of practice, plus I'm doing the other one later, the assignment that I gave you yesterday, and I'm giving you another assignment today with mixed problems. So there I rewrote it, as we know all so well, And what is this going to be? So maybe some kids would be confused, all this math here, but really I'm just factoring what's inside here. So what number works? 2x works. And what's left? 3x plus 2. Does everybody see that? Work it backwards, write it out, cancel. There are lots of ways to double check. And then you can see that when you write 3x plus 2, that is repeating this. There's the second parentheses. I'm just missing the -1. So there's 3x times 2x minus 1 times 3x plus 2. And that's the complete factorization of this cubic trinomial, which in this particular case is representing a rectangular prism. And so I'll turn the camera back here and fill in the dimensions in any way I choose. With restrictions, obviously, in a serious math problem. But we won't get into restrictions here. And this might be one of the many possible answers. And now, a lot of times I commit this sin. I don't answer the question. I do all the hard work, but I don't answer the question. They want to know what the length of the edges is. So it would be 4 times 3x plus 4 times 2x minus 1 plus 4 times 3x plus 2. Expect this kind of stuff on the regions. This is their comfort level, if I can use that term, okay? And now I'll go sideways. So it's going to be 12x plus 0. See what I did? And I'm just organizing my like terms, so I put a 0 there. You certainly don't have to do that. 8x minus 4. Where did I get the 4 one more time? If you look at the figure there, and we've done it so many times in the past, you can see that there are 4 lengths and 4 widths and 4 heights and all that. You did in 7th grade as well. And finally, it's 12x again, but this time plus 8. So there's 4, 24. So this happens to be the length of the edges, happens to be 32x plus 4, subject to restrictions, of course. And I got it down there. Okay, so I did that one for you. I'll send this video out this morning. And let me lift it up again with the work we did, and I'll give you assignments on this. You can definitely expect this stuff on the regions. And there we go again, where I worked out the problem, and there we go when I lower it. That's the length of the edge is 32x plus 4, of course subject to restrictions. Okay, so there we go. And I'll get this out to you this morning, and then we'll talk about assignments.